Alright, today we're talking about trig inverse values with the calculator. We're going to do both degree mode and radians today, so go ahead and identify the mode key on your calculator. Y'all are going to have to be using your calculator and just kind of trying to do this along with me, making sure you're getting the same answers. So the mode button is next to the second button. If you push that mode button and arrow down 3 times, right now your calculator is probably set to radian. It might be set to degree, but if you just arrow right and left, you can set it and push enter to whichever one you need. So if you look at question A, it's in degrees, so go ahead and arrow over, go to the degree, push enter, and then second quit is actually that same button mode. So second quit, go back to the home screen. So now you're going to type in cosine of 39, and cosine is above, look at the 8 key, go above that is the parenthesis key, and go above that is cos, C-O-S, cosine. So type in cosine 39, close that parentheses. It's good practice to go ahead and close that parentheses. So you should be getting 0.777. We are going to round to the thousandths, so that 1 tells the 7 to stay the same. So this is 0.777. All right, question B, sine 212. So now you're typing in sine 212, close the parentheses, push enter, and we get negative 0.5. Okay, before you write the 9, look at the 9 after the 9. It tells that 9 to go up, which makes it actually 30. Make sure you are rounding correctly. Really quickly, look over to this question. It says, why is this value negative? And it's because of the fact where 212 degrees is. 212 is way over here. So if you drew that triangle, notice that your opposite would be down. And so when you go down, we know that that's going to cause a negative opposite, which will be a negative sine value. So that's why the sign here is negative. All right. C, cotangent of 56. This is where the real problem occurs. This is why the main reason why we're talking about this. There are only the sine, cosine, and tangent buttons. And so when you want to use cosecant, secant, and cotangent, you have to do a different way of doing this. So keep in mind that when we first defined those reciprocals, we said that cotangent of an angle is equal to 1 over tangent of an angle. So instead of typing in cotangent of 56, I don't have that button on my calculator, so I'm going to have to type in 1 over tangent of 56. All right, so we're all on our calculator right now. Type in 1 divided by. Now you do tangent 56, close that parenthesis. We should get 0.675, rounded correctly, is 0.675. All right, let's keep going. Secant of 245. So when you're doing secant, there's, again, not a negative button, or I'm sorry, not a secant button, so we're going to use cosine. So this is 1 over cosine of 245. So 1 divided by cosine 245, close the parentheses, is equal to negative 2.366. And then lastly, we'll do the cosecant. So we know cosecant is the reciprocal of sine. So we're going to type in 1 over sine of 125. So 1 divided by sine 125, close it, is 1.221. All right, keep in mind what we've just said is that cosecant of this angle is equal to 1.221. This is the ratio that this is equal to. You have to really get familiar with that. It's going to become really important that you know when you're talking about an angle and when you're talking about a ratio. So let me just write that really quick. Trig of any angle is equal to the ratio. And sometimes what we're looking for is what the ratio is equal to. Sometimes what we're looking for is what the angle is equal to. So if we're looking for what the angle is equal to, you need to put the trig on the other side. And we do this by using inverses. So then I would have an angle equals whatever that trig is, use its inverse, and then that ratio is now here. And so this is trig inverse. Okay? So, if we look at theta equals sine inverse of x. So that means that an angle so that means that any angle is equal to and since you see the inverse sign, that means that the variable next to that inverse sign is the ratio. So it's equal to the ratio of sine inverse. Okay, and so I could also write it in these different fashions. Okay, so let's go on. We are also going to do the ratios and what the angle is equal to today. So theta is equal to cosine inverse of 0.619. So what you're looking for is what angle equals cosine when it's this ratio, 0.619. So this is one that we do indeed have the button for, so y'all are just going to type this into the calculator exactly how you see it. So cosine inverse, look at your cosine button on your calculator. If you notice in that on that same button, but in blue, you should see cosine inverse, so you have to push the second key and then that button, 0.619, close parentheses. So you should be getting 51.757 if you put that in correctly. If you didn't put that in correctly, rewind and try to get this correct answer, 51.757. And so keep in mind what you just found is an angle, so that's 51.757 degrees. Okay. Next, arctan. So we're doing theta equals arctan 2.471. Arctan is the exact same thing as saying tan inverse. So you could say theta equals tan inverse of 2.471. So theta equals, now you're going to do second tangent to get tan inverse, 2.471, close it, is 67.967. Again, this is degrees. Okay, now C is where it starts to get a little tricky because this is again the situation in which I don't have a button for. So I'm going to explain this pretty thoroughly before I show you or tell you how to put it in your calculator. So we know that secant of theta equals h over a. So therefore theta equals secant inverse of h over a. Now this is basically what I have here. Instead of seeing a ratio, you just see a number because they've simplified it or put it in the calculator. So you don't actually see a ratio here, but 3.156, you could always say that that's over 1, and so that would be your ratio. Now the problem is I don't have this in my calculator. But we do know that instead of using secant, if I still wanted to talk about the ratio h and a, I could say, well, instead, I know cosine of that theta would be a over h. So that theta would equal cosine inverse of a over h. Now, assuming we're talking about the same a and the same h, this is the same a and the same h, I can use cosine inverse, and I would just flip that ratio inside the parentheses. Okay, so that's what this says over here. So if you don't have the button, if you see the little -1, change to its inverse function and flip the ratio. And so this is really trying to explain to you how to do this. This is what we're going to type into the calculator. So cosine inverse 1 divided by 3.156 is 71.527 degrees. Okay? All right, so if I'm going to do arc cosecant of 1.982, then I need to do something besides cosecant, so I'm going to use sine, because sine is the ratio of cosecant. So I'm going to say, well, theta could also equal sine inverse, and if I'm going to change it to sine, I need to flip that ratio, so it's now 1 over 1.982. So if you type in your calculator sine inverse of 1 over 1.982, you're going to find that the answer is 30.301 degrees. Okay, so really quickly, let's do cotangent. So let's solve this for theta really quick, because that's the variable. So theta equals cotangent inverse of 0.684. I don't have the button for cotangent inverse, so I'm going to have to use tangent. But if I'm going to flip this to its reciprocal trig, then I'm going to have to flip this. So now I'm going to use tan inverse of 1 over 0.684. This is what you're going to type in the calculator to get your answer. All right, at the bottom of the page, exact same concept, but now we're in radian mode instead, but it is the same thing. So this is saying cosecant of an angle, and this angle is in radians. By the way, if we're going to use radians, I should really start getting into the habit of typically you use x for radians, and theta is typically used for degrees. So this is cosecant of x. Notice that I don't have that little -1 here. That means that since I don't have the cosecant button, I'm going to type in 1 over sine of that angle, and in this case that was 2.9. 2.9 is the radian. That's why it doesn't seem like it's a real angle, but it's 2.9 radians. Keep in mind that pi is like 180 degrees. So pi radians is 180 degrees. Pi is 3.14 approximately. So this is almost 180 degrees. If you wanted to convert that, I mean, you don't do that, but I'm just saying this is kind of close to 180 degrees. So this is what you're going to type in the calculator. Make sure you go to the mode and change it to radians before you do that, though, because now we're in radians. So 1 divided by sine 2.9 is 4.1797, actually 4.180. Oops. Okay, so secant of 3.89, I don't have a button, so that's going to be 1 over cosine 3.89. So 1 over cosine 3.89 is negative 1.365. Okay, and tangent of 4.2, I do have a button for that, so I just type that straight in. Tangent 4.2, 1.778. All right, and that's it for the front, so let's go on to the next page. All right, so if we find the radian measure of the acute angle x, so this is what I'm talking about. Since it's a radian, we're going to use x. This is saying your angle is equal to secant's ratio 2.712. Personally, I don't like the arc. I know it means the same thing. I just don't like to use that as much. So if you want to take that step of saying that's the same thing as saying x equals secant inverse 2.712. I just like to do this because that's my rule. I see the little -1 here, so that means I'm going to flip what's inside because this is the ratio of secant. If I'm going to use cosine instead, then I need to use the reciprocal ratio, because that's how secant and cosine are related to each other. So this is what I'm going to type into the calculator. So cosine inverse 1 divided by 2.712, close it, is 1.193. Keep in mind what you just found. This is the radian measure of the angle that gives you this as secant's ratio. Okay, so cotangent inverse of 5/7. Now this is a problem, it's kind of interesting because you actually see the ratio 5/7. So this one actually kind of helps you make sense of what exactly you're doing. If this is cotangent and cotangent is A over O, if I'm going to change that to tan inverse, tan is O over A, so that 7 is now on top and that 5 is on bottom. This is the same thing as doing 1 over 5/7. This just is prettier. So this is what you type in the calculator. Tan inverse 7 over 5 is 0.951. So again, this is the radian measure that gives you this cotangent ratio. All right, and so x equals sine inverse 0.627. Now don't just get used to always flipping. I have a button for sine inverse. I don't need to do any flipping here. So sine inverse 0.627 is 0.678. All right, and that's it. Let's go down. Find theta in degrees and then find the given function of theta. Do not clear your calculator in between steps. Confirm your answer by sketching the angle. All right. So what I'm doing here is first pretend like all we've ever done is used a calculator. So if this is what you know, and I wanted to solve for my angle, then I would say theta equals sine inverse 3/5. So theta equals, if I'm using theta, I must be in degree mode, so change your mode on your calculator and type in sine inverse, because I have that button, 3/5 is 36.87 degrees. All right, so the picture that it's wanting you to draw is you draw a right triangle, and it's saying that if your theta is that 36.87 degrees, your opposite would be 3, and your hypotenuse would be 5. And if we wanted to know what tangent of that 36.87 degrees is, you're going to type in tangent, use the second key, and then use the negative key, not the minus key, the negative key, and you should see A and S pop up. That means it's going to put in that exact answer in your calculator, and you should get 0.75. So if you finish the picture, we know this is a 3, 4, 5 triangle, and it makes sense that tangent of that theta is 3/4, which is 0.75. All right, so let me do that one more time. If cosecant of theta is 7/4, that means theta is equal to cosecant inverse 7/4, which means that that's equal to sine inverse of 4/7, which is equal to, so sine inverse 4/7 is 34.85 degrees. Now I'm going to type in secant of that answer. Well, I can't type in secant of that answer, so I'll have to type in 1/cosine of that answer. So 1 divided by cosine secant A and S is 1.219. Okay. All right, let's go on. All right, so we did give you some steps here. This is the steps that you're going to follow. So let's just try to make sense of this before we start, and then I'll kind of go over those steps. So theta equals sine inverse of 0.752. This is an easy example because you can type this straight into the calculator. I'm sorry, I forgot my inverse. You can type this straight into the calculator. So sine inverse 0.752 is 48.764 degrees. So theta is 48.764 degrees. Now you go back and look at where you're supposed to be. So if you wanted this to be in quadrant 2, we would draw a reference angle, and this reference angle is supposed to be that 48 degrees. Now the goal is to find the standard angle. Well, if this is 180, then I must be landing 180 minus this amount would be how I would get to it. So now type in 180 minus second ANS. So you should get 131.236. That is your answer. Okay, something interesting to note. If you are going to satisfy your location purely based on your reference angle that's always positive, then you should always use a ratio that is positive. And that's going to be one of these key important steps that's listed over here. It says solve for theta ref. So we solved for theta ref in this step, and we got 48.764. But it says find theta ref but ignore any negative sign. I didn't have to do that step because my ratio was already positive, but if this ratio had been negative, I would have ignored that and still gotten this answer. And then you satisfy the quadrant. So example B is a lot harder because you have to go through that step of ignoring the negative sign. So theta equals secant inverse negative 5.127. So theta equals, I can't use secant, and I also don't want this negative sign. So I'm going to change this to cosine inverse of 1 over. I'm going to change this to cosine inverse of 1 over positive 5.127. By doing this, I am finding theta ref. The goal is to find theta standard. This is how I'm going to find the reference angle. The reference angle is always positive, so your ratio is always positive. Then I will draw my triangle like I did here and get the theta standard that I need. So cosine inverse 1 divided by 5.127 is 78.753 degrees. I'm supposed to be in between 180 and 270. So this is theta ref of 78 degrees. And if this is 180 degrees, then I went this much around plus 78 more. So I'm going to say that plus 180 is 258.753 degrees. That is your final answer. And we're going to ignore example C. So 258.753 degrees. And that is it for our notes today.